Hello everyone. How are you guys doing today? So, or our exam will be EXAM2 will be day after tomorrow, Wednesday. I didn't make the exam yet. I want to make it really short so that I can grade in few days, 2 days, because the last day to drop that class is Tuesday. So I have to give you everything before Monday, and there is no class on Monday. Monday is a holiday. So we are going to see again each other on Wednesday, which is after the dropping date. So what I'm going to do is I'll grade your exam over the weekend as soon as possible, and then post the grade on Brightspace, and then you'll see why you're standing. I also post a calculator where you can play around with the numbers and see how much you need to have in your third exam, final exam, and the homework in order to pass this class if you desired grade. Is there anyone who doesn't want to get A here? Like happy with D, C? Is there anyone who is happy with C or D? No, right? You all want A, if I'm not wrong. How about B? I guess okay with B? B is fine. So you can see with the calculator how much exactly you need to have your A or B. And if you see that there is no way you can make it to B, drop it before Tuesday. And before you do that, make sure you talk with the counselor. All of you have your counselors, right? If I'm not wrong. So before you withdraw, make sure you talk with your counselor and see what you want to do. There are a few students who has not done any homework yet, and I'm really angry on them. Okay, homework is 4%, 20. Homework and attendance, homework and quiz, including attendance, at 20%. So if you're not doing any homework or not taking any quizzes, you're losing your 20%. So how are you going to get A or B? You're not going to even get B minus. The highest you can get in this class is C if you don't do any homework or quizzes. So if you're here for A and B, forget about that if you're not doing your homework or quizzes. Homework and quizzes, including your attendance, 20%. So from 100%, if you subtract 20%, that means you're losing 80%. So highest you can get in this class is 79. If you have all 100, 100 in exam 1, exam 2, and final exam. If you have all 100, then you can get 79, which is C plus. Okay? So I'm warning you guys. Don't give me a hard time. Don't make me angry by not doing the homework. And for the homework, you have your AI friend, right? So if you don't understand anything, ask your AI. Why, how to solve this? Why the step is this? Have a conversation like a tutor, like how you have a conversation with your tutors. Well, what is the first step? Why this is the first step? Do it with ChatGPT, with what else we have? Cloud, ChatGPT. I found Cloud and ChatGPT are the best, but ChatGPT is worse for math. It's best for research paper and everything, but it doesn't help much. It doesn't even know how to do order of operation correctly, ChatGPT. So don't trust ChatGPT. Cloud, Cloud, CLAUDE. Cloud is much more reliable than ChatGPT format. Use Cloud. It's free. And yeah, play with that. There is one more thing, Perplexity, but Perplexity is not as good as Cloud. For math, Cloud is one of the best. ChatGPT is one of the worst. Okay? So if you don't understand anything in the homework, go play with your Cloud or search on Google. Actually, most of the questions are available on Google. So search them and see how to solve them. You don't have to copy them, just understand the process. As long as you know what you're doing, you're fine. Plus, you see, the homework questions are way harder than what we go over in class, because in real life, what we have in class, actually we use. What you have in the homework is to push you to the next level, okay? So push yourself to the next level by doing a homework and test yourself by your quizzes. They are open book, open note, open AI, because I'm not singing, right? So you can do anything, whatever you want to do to complete your homework and quizzes. I just want you to study for my exam honestly and take them honestly. Okay? Besides, outside of my class, what you're doing, I can control you. So it's your life. Go ahead. Any question? I'm planning to give some question so that I can see how you're feeling about the class. So yeah, I might email you with some questions. And please do them nicely, not in one word or one sentence. No, I don't have any problem. No, I don't want to say anything about it. I don't want to hear it. I want to hear your honest opinion. So how you express about this class to your friends or relatives or anyone else outside of the classroom, say the same thing on your paper. I'm not going to penalize you for what you're saying. I just want to get your feedback. I want to know how you're feeling about this class, the materials and everything. Okay. I love reading them. That's why. Any other question? And yes, I'm planning to have, like last time, one easy question, one harder question. So whichever is easier for you, you can pick your choice and do them. Any question before you start? No? So does anybody have any question on the past two? Question 1 and 2. Question 1 is saying, by looking at the function, connect it to the definition and see what's the original function. I did not ask you to find the derivative using definition. You're just finding the function. The derivative is given when x is 5. So what's the function for x? So the definition is limit h goes to 0, f of x plus h minus f of x divided by h, right? Now, what they give you is the exact same thing. It's limit h goes to 0, 1 over 5 plus h under the square root over 1 over 5 under the square root over h. Now, if you compare these two, this is the derivative for any x value, and this is the derivative only for when x is 5. So when you compare these two, what is the original function? Do you see the original function there, Lana? 1 over radical 5 is function when x is 5. And you're asking for, so f of 5 is 1 over square root of 5. What is f of x? That's it. The trick is this. See, whatever you have after the subtraction sign, that's your function. In the derivative, they are saying when the x is 5, this is what you have. So that means when your x is x, what is your function? Just replace your 5 with x. Why do I have this? See? It's not a math question, tricky question. I mean, it's a tricky question, but it's not a solving problem. Okay? I would like to give one of these in the exam to see, to test your, what is called? What's the word? Say it again. Observation. Yes, good observation skill. If you have good observation skill, you can see that f of x is the thing after the subtraction sign, and all you have to do is replace whatever number you have there with that. That's it. How about the second question? Rate of change. How do you find rate of change? There's given a there is a function given which is question 2. F of x is negative x cubed plus 7x plus 1. What is its rate of change on the interval 1 to 4? Slope of the second line. That's it. We are looking for slope of the secant line. This is average rate of change. That means you have to remember what's the slope. So what's the slope of the secant line? F of b minus f of a whole thing divided by b minus a, which is same as what you did in algebra, y2 minus y1 over x2 minus x1. These are the exact same two things. So smaller one is always a, bigger one is always b, okay? Every interval runs from a to b, means smaller number is a, bigger number is b. Now we need to know what is f of b. So let's find f of b here. F of b means we have f of 4. So negative 4 cubed plus 7 times 4 plus 1. And then you need to know what is f of a, which is f of 1, negative 1 cubed, 7 times 1 plus 1. Whatever you have, put down the formula divided by b minus a, and you get your solution. I'm not completing them, I'm just giving you the direction. How do you proceed and what do you do? Any question on this one? Do you remember where f derivative doesn't exist? There are a few cases, right? So f prime doesn't exist. Where? Sharp turn. And jump. And vertical asymptote. There is one more place. Oh. If you see any of these 4 in your graph, the derivative doesn't exist. In 3 of these, function is not continuous, but only one place function is continuous. So in which scenario function is continuous? Is the function continuous at the vertical asymptote? Is the function continuous at the hole? Is the function continuous at the jump? That means what is the only place the function is continuous, but the derivative still doesn't exist? Sharp turn. In one place function is continuous, I should write f. F is continuous, and in these 3 places, f is not continuous. The first one is too small. Let me work with this next one. So in the blue graph, where the graph is not, where the function is not differentiable. X equals 0 because we have a vertical asymptote. Anything else? X equals 3y per term. So in the exam, I'd like to give you both choices, like why is not continuous and why is not differentiable, and why the reason. What's the problem at that place? So you'll get individual points for each part. Any question? I said I would like to give separate points. So one for answer where and 1 point for the reason why. So 2 points for one place. And also I forgot to put that before in the review sheet. Based on the graph, decide its derivative, or based on the derivative, decide the graph. Both way, okay? So here it says based on the function below. So f is given. Based on the f, decide what's the f prime. So we should remember the rules. When f is increasing, what happens to the derivative? Derivative is positive. When f is decreasing, what it tells us about the derivative? Negative. Okay. And what does positive mean? Above x-axis. So it means it lies above the x-axis. And negative means it lies below the x-axis. And there is one interesting scenario when the derivative is exactly 0. It crosses the x-axis. Cross the x-axis. And when the derivative is 0, what happens to the function? It's a bump. Either we get a local maximum or we get a local minimum. So here, the purpose behind this type of question is to know whether you understand the relationship between the function and its derivative. So if you did understand them, based on the function, can you draw its derivative? Where do you think you should start? So first, you're going to start with below the x-axis because in the first portion, our function is decreasing. So let me change color for each. From here to here, it's decreasing. And they give us the point A, B, C. Okay, so let's also write this is A, this is, should I have a little bit on that? Let's say this is A, this is B, and this is C. Now, before A, the function is decreasing. So we have a portion that is below the x-axis. What happens at A? We have a bump, so we're going to cross. So we cross here at A, which is here. And then from A to B, our function is increasing and we have a bump on B. That means we have to cross our graph through B. And where do we have the portion between A and B? Above or below x-axis? Above. So the only way we can cross A and B is by having a circular thing, some type of parabolic shape. And then the next thing from B to C, it's decreasing, and at C, we have a bump. That means we need to cross the x-axis to C, and since the function is decreasing, what is happening between B and C? Is it above or below? Below. So we need to draw it, some type of U shape again. And lastly, we have a graph that is increasing forever. So how are you going to draw the part after C? Above or below? Above, somewhere. So the left side is going yellow. It's going down forever. On the right side is going up forever. And between, we are going up and down, up and down. Any question? If I give what? The other way around. So let's see, do I have this question here? From derivative to the original, derivative to original, derivative to original, derivative to original. Okay. So I don't have that example, but I was planning to give that in the exam. So let's do one example. Let's say this one, okay? Let's say this is the derivative shape. So this is f prime. This is the x-axis, this is the y-axis. And let's say this is A, B, C. Okay, so other way around. Since we are crossing the axis at ABC, so what happens to the function at ABC? It's bump. All of these are bump. And now before A, we have the portion above the x-axis. So what type of function are you going to get? Increasing or decreasing? Increasing. So above x-axis means an increasing function. And then we have some type of bump. It could be below or above, not sure, anywhere, but we do have a bump because of crossing the x-axis. And then from here to here, it's below the x-axis. So what type of direction we have for the original function? Increasing or decreasing? Decreasing. So we are going down. And then we are crossing the x-axis through B. That means, so this is A, and here should be B. So we stop B here. We have a bump, so we're crossing the x-axis in the derivative function. Once we have a bump, then look at the next part. From B to C, what is happening to the derivative? It's above the x-axis. That means the original function will be increasing. And then what happens at C? There is a bump because you're crossing the x-axis. And lastly, after C, our derivative is below the x-axis. So what is happening in the original function? Decreasing forever. So the bumps, these are not accurate. You don't have to be accurate. The main idea is, how do you know how to draw a shape based on your derivative. Shian. Huh? Concavity. Concavity in the last part. Do you want to know about concavity? What is your question? You don't have to show concavity. There is one question. There will be one question in the last part where you're going to do question like this. One function will be given. Find where the graph is concave upward, concave downward, based on the second derivative. You don't have to find it from graph to find concavity. You don't have to find the concavity from the graph, but you have to find the concavity from the function by using second derivative. For the graph, you don't have to remember concavity. It's only the first derivative to the original function, function to first derivative. That's it. Okay. Now let's do these two interesting questions. The blue are original graph. Yeah, that's what I said. The shape doesn't matter as long as, you don't have to be accurate. The main thing is the shape, how it's moving up and down, up and down. So definitely it's not correct because my axis is off. It's like you don't care about the exact shape. Like the W. We have a W graph, so what's this derivative? The first one. The graph is a W graph. Which one is the derivative? A, B, C, or D? You think it's B? Anyone else? It's okay, you all can guess. We're going to do them together, no problem. He was brave enough to guess first. Anyone else? Just doing. You also think it's B? Yeah. Anyone think it's not B? No. Alan, what do you think? B or not B? B? Okay, let's see. So this is the original graph. Original graph is decreasing. First you have to start from below the x-axis. This graph starts from below the x-axis. This graph doesn't, this graph doesn't, this graph doesn't. So if you have one hint, you can stop. Okay. So it should be B. But if you want to try more, no problem. Once you decrease, then you increase. So once you is below x-axis, then you're above the x-axis, and then it cross to 0, and then it's decreasing. That means it's below. Then you're touching your x-axis. Well, actually, I shouldn't say cross. I should write x-intercept. Because in order to be x-intercept, you don't have to cross. You can just touch it. That's how I'm going over them. And lastly, you have, which one I didn't use? Yellow. It's increasing, it means it's above the x-axis. You have to do both. How do I know which one you understood? So I'll give you at least one from function to derivative, at least one from derivative to function. So derivative to function is this example. When you look at the derivative, there are only two things you look at. Whether it's above or below the x-axis. Okay, based on either above or below the x-axis, the original function will either increase or decrease. So f increase, decrease, but the derivative is either above or below. We don't care about increasing, decreasing derivative unless you're working with second derivative. So to have a second derivative and to make it like easier, all you have to do is see which part is above and which part is below x-axis and where they're crossing the x-axis. So they are crossing the x-axis at A, B, C, it means in the original function, we are going to have a bump at A, at B, and at C. Now, the first part is above the x-axis. That means we have to draw a function that is increasing. So I started from here. If you go above the axis, how can you increase? Oh, if you go above, sometime you have to go down, right? Because it's not, it doesn't have any asymptote. As long as you're working with polynomial, the graph will always go down. You can start from above, no problem, but in reality, it will, in long run, it will go below the x-axis anyway. But yes, no problem starting from above the x-axis. So somewhere we have an increasing part. So for the above part here, before A, we have increasing function. Exactly at A, we have a bump because you're crossing the x-axis here. So an x-intercept. And then between A to B, this portion of the graph is below the x-axis. Below means the original function is decreasing. So you decrease here. And then see at B, you're crossing the x-axis, you have an x-intercept. That means you have to have a bump here. So you change your direction and you go based on this part. Between B and C, it's above the x-axis. So you have to have an increasing part in the function. So that's why you're increasing from your B to C. So this is the C. And then after C, the green part is below the x-axis and it's always below the x-axis. So we have an eternal decreasing function and we have a bump at C. That's it. Any other question? So these are easy. And next one is the implicit differentiation. So I'll give you two, one with the regular function and one with trig function. No, I'm too used to the arrow, so most of the time I actually draw the arrow. We don't have to do the arrow. Now, for implicit, do you want me to go by any of the question? Do you specifically find anything is hard here? Any question is hard? Logan. Oh yeah, I forgot about that. It's an interesting question actually. Thank you, Lana, for reminding me. So this is the original function. Can you guess its derivative? Bottom right. Bottom right. D. Anyone else? D? D? Okay, let's see. So first we have an increasing, which is above the x-axis, makes sense. And then the interesting thing is here. What is happening here? Derivative doesn't exist. Derivative doesn't exist on a straight line, straight vertical line. I actually forgot to tell you that. Vertical asymptote whole, and there is one more scenario. Vertical line. Derivative exists in the horizontal line, but it doesn't exist on the vertical line. So that's why we have a vertical asymptote here, because in this portion, the derivative doesn't exist. And then after that, the derivative is above, the function is increasing. So we have a portion that is above the x-axis. So increasing function means derivative is above the x-axis. So we have two portions that is above the x-axis, which is either this or this. Definitely not this, definitely not that. Now, difference between B and D is that B derivative exists everywhere, but for D, derivative doesn't exist at the origin. So only this makes sense, this doesn't make sense. Because of the vertical line, we cannot have a derivative, continuous derivative. Okay. Any question? I might give you something tricky like this. Now, implicit, do you want me to go over any of the question about the implicit differentiation? D. Okay. We have 8x squared plus 3xy minus y squared equals 4. Now, you can find the derivative directly, or you can keep your y's together and get rid of everything else on the other side. So you can subtract 8x squared. This part is optional. We have 3xy minus y squared is 4 minus 8x squared. I like to do that because in that way I can have all the y prime in one side and not y prime to the other side. And now we have x and y together. Do you remember what do you do when we have x and y together? How do you find the derivative? Do we just find the derivative like x prime and y prime? In other words, you're talking about product, right? So anytime we have x and y together, we must use product rule. Oh, Nicholas, you're online. I didn't notice that. Product rule. If you guys have any question, Nicholas and Mustika, unmute yourself, okay, and then ask me. So product rule. So for product rule, let me refresh your memory. Let's say the first function 3x is f, and the second function just y is the g function. In that case, what is f prime? What's wrong, guys? Go ahead. 3. And if g is the y, then what is g prime? Y prime. Derivative y is 1, but we must do the indication y prime. This is y and this is g. So f prime g plus g prime f. F prime is 3, our g is y, plus g prime is y prime, and our f is 3x. That means in order to find the derivative 3xy, you need to use the product rule. And then we take the derivative of the y squared. What's the derivative of y squared? 2y and then y prime. What's the derivative of 4? 0. What's the derivative of 8x squared? 16x. So we have 3y plus 3xy prime minus 2y prime equals negative 16x. Our goal is to solve for y prime. Do we need the 3y on the left side? No, we don't. So we get rid of the 3y from both sides. So we have negative 16x minus 3y from left to the right. And what do you notice here? How can you solve for y prime? What do you have to do? Factor out. So we factor out the y prime and we get 3x minus 2y. Our y prime is almost done. What is our last step? Do you add, subtract, multiply, divide? Which one? Divide. We divide both sides by 3x minus 2y. So we have y prime is negative 16x minus 3y, 3x minus 2y. Now, if there's a find equation of the tangent line, which is the next question. Well, we're going to do it later. Never mind. That's what we have to do. Take the derivative, bring everything to one side, and leave your y prime alone to one side. Any other question? If you ever have fraction over fraction, you have to flip the denominator. And you actually don't have to have fraction over fraction because this is actually very easy. You have x over y cube equals 2. If you find the derivative, definitely it will be on the denominator. You don't want to have derivative on the denominator. So what can you do so the derivative will not be on the denominator? Is it number 1? Is it 3? Oh, 3a. Okay. Yeah, anytime you have fraction over fraction, simplify. But about this one, all you have to do is cross multiply. So you get x equals to y cube, and then take the derivative. In that way, you don't have to have any derivative on the denominator. And if you ever have derivative on the denominator, it's not acceptable. You always have to have derivative on the numerator. So do something so that the derivative always stays on the numerator, not ever on the denominator. Do you want me to go over any other question? Which one? Pick one. Which one looks bad? A. Okay, let's see. 3a. 3 plus 5x equals sine xy cube. So we have nothing to get rid of on the right side. It's one single thing, sine xy cube. So that means we go ahead and find the derivative right away. What's the derivative of 3? 0. Derivative of 5x? 5. And now, which derivative rule we have to use to find the derivative here? Chain rule. So first we start by sine. What's the derivative of sine? Cosine. So we changed the sign. That means we cannot change its angle. You're always allowed to change on one function at a time. So first you change the sign, you have to leave your angle alone. And then you can change the angle. For angle, we have xy cube, x and y together. So you cannot just find the derivative right away. You have to use which method to find the derivative? Product. So let's say this is f and this is g. So f prime, what is f prime? 1. and G is y cubed. And then G prime F. So keep power F. And what is G prime? What is derivative of y cubed? 3y squared. And don't forget about your y prime. Anytime it is the derivative of y, always to indicate that it took the derivative of y, so it's y prime. That means here you're multiplying by y cubed plus 3xy squared y prime. What you're looking for is this. We want to make this single. Oh, so you're talking about that fraction of a fraction. What trig exactly, little one? So what do you think you should do next? You have 2 ways to go. If you want, you can divide by cosine of xy cubed, which is not invalid, it's valid, but it's a bad approach because you're going to have a fraction of a fraction. So we have 5 over cosine xy cubed, and on the other side we have y cubed plus 3xy squared y prime. Let me erase this. You can do this work mentally. Okay, so again, this is what you're looking for. So what do you get rid of next? Y cubed. Do you add, subtract, multiply, divide? Which one? Subtract. So minus y cubed minus y cubed. We have 5 over cosine x y cubed minus y cubed 3x y squared y prime. And then lastly, if you want to y prime alone, what do you do? By 3xy squared, 3xy squared. So whatever we have here, this thing is the y prime. It looks bad, that's why I say it's a bad approach. The good approach will be distribute the cosine to both, and then you do individual parts. But you don't have to do that. And for this, I understand it's horrible. So leave it, no problem. Any other question? So that's how you do implicit differentiation. You take the normal, just like the regular derivative. The two differences, once you have x and y together, it's always product rule. And anytime you take the derivative of y, you must indicate that it's y prime. Now, in the second one, I'm going to give one question about tangent line. Find the equation of the tangent line. And I'm not going to do all the way thing. I'll just tell you the steps. So this is x and this is y. Or this is x1, this is y1. So any type of equation of a line is y minus y1 slope x minus x1. It's any type of line. It could be tangent line, could be secant line, could be horizontal line, could be vertical, any type of line. You can start by that. It has, this is the format for any type of line. Now, in this format, you never change y, never change x, because every formula has to have x and y in them. Otherwise, it's not an equation. So leave your x and y alone. Don't ever replace them with anything. We are going to replace y prime, m, and the, so not y prime, y1, m, and x1. So they gave us the y1, 1, they gave us the x0. If one of them is missing, you can plug that in into the original function to find the other one. If x is missing, they'll give you the y, put y, and then solve for x, which actually they never do. They always give x, and sometimes they give x, sometimes they don't give x. If they don't give x, you just substitute x in the original function and get the y value. Once you have your x and y, these are the x1 and y1. Now you need to find your m. How do you find m? Derivative. So it's the derivative for x equals the x value they give you. So you see, when you find the derivative, we get an equation, right, of the derivative. So if you try to substitute m with the equation, it doesn't make sense. What you're going to do is, once you find the derivative, substitute x and y with the numbers for everything, every x and y you see in the function, in the derivative, and then you get a number, slope. Substitute that slope here, and then you're done. Unless it specifically said write the equation in a specific format, like in slope-intercept format or in standard format. If they don't mention the format, once you substitute everything, you're done. Sorry, it's 0. Because this is 0. And also they give us y, and most likely we have a derivative with x and y. So x0, y1. You find the derivative, substitute x and y with the given number, get a number for the derivative, substitute here. So x1, y1, m, all of these are numbers, not variable, not equation. Okay? Any question on implicit? So on related rate, you may have one question or may have two questions. If I give you two questions, one of them will be something like this, and one of them is the what problem. And if I give only one, then one will be the what problem. So I'll see. It's based on my paper. If I can fit one, two, then I'll give you two. But if I have only one space for one, then I'll do one. I want to make it smaller, as small as possible, so that I can grade easily. That's my goal, grade easily. So what do we do here? What they're asking for? Is it too small? They gave us a function, y equals x cubed minus 3x. They want us to find dy dt when x is 2 and dx dt is 3. Find the derivative and substitute. That's all you have to do. What's the derivative of y? Can I write y prime here? We cannot, because y prime usually means dy dx. So are you working with dy dx here? So if you write y prime, it will be wrong. It's not correct. So it's dy dt. What's the derivative of x cubed? 3 x squared cube. And then don't forget about dx dt. So in the previous section, we did not put any indication for x, but in related rate, we are not working with only x and y, we are also working with time. Anytime we have a third variable, you must indicate that. So we have the last term, 3x. What's the derivative of 3x? It's 3, and then dx dt. They are looking for dy dt. What is dy dt? It's this thing. Do we have every information? Do we know what is x? X is 2. Do we know what is dx dt? 3. And then whatever you have, that's the answer. And let's say your derivative has a y in it, but they did not give you y. What do you do then? See here, we didn't have any y here, right? But let's say the example you have, it had a y. Good. Anytime something is missing, all you have to do is plug the given information to the original one, solve for y. So in the example, you may see something where y is missing, but you actually have to find the y. And then Gilstead rate. Which one? The last one? If you don't like it, ignore. I'll give you something easier. Okay. The last one is for LN. Similar question will be for LN. But for you guys, something easier from the past 3. So which one you like the most in the past 3? Which scenario, which shape? A sphere? Oh, you have 2 sphere. I should have picked something different. So we have sphere, triangle, square. What else we had in class? Cylinder. So we had triangle, we have sphere, we have square, we have cylinder, and we have cone. Cone is for Ellen only. The last one. It's challenging. But besides that, from the 4 shape, which shape you like the most? Square? All of you agree? Okay, then I'll give you something with the square. Do you want me to go over any question here? I already told you what to bring the exam, right? So go ahead and watch the recording from the square video. What's wrong? Okay, linearization. I didn't go over in class, but there definitely will be two questions. One is about the linearization and one is about the differential. So linearization and tangent line, they have the same formula. All you have to do is do a little bit work for linearization than what you did for the tangent line. So question like, find the linearization of this function for square root of x at x equals 100. So what's the linearization for square root function when your x is 100? So the linearization is this. Basically, you're finding the tangent line. It's not exactly the tangent line, but they have the same information. So all you have to do is find the derivative, substitute your derivative with the number they give you, substitute your y value. To find the y value, substitute the function with that number, substitute your x1 with that number, and then leave the x alone. In linearization, you don't substitute your x, leave this x alone. Besides x, substitute everything else with the number they give you. L of x, the linearization. So L of x means linearization of x or linearization at x is this function. So yeah, you don't substitute L of x because L of x is the function. So you don't substitute these two. L of x with the y and x. We leave a y and x alone, and you find everything else. You know how to find everything else, right? To find f of a, substitute just a there. To find derivative of a, first find the derivative, substitute a, and then just substitute everything, simplify. That's what you have to do. The second versus use the linearization to approximate a number without using calculator. So we know square root of 4 is 2, right? So they are saying, well, if you know square root of 4 is 2, what is square root of 3.9 or 3.99 or 3.999? We know by definition, I mean not definition, by our knowledge, it's definitely closer to 2, right? But do you know exactly how much is it? We don't. So we can use the linearization to find that out. What you're going to do, once you find your linearization equation, this is the x value you substitute. And then simplify. That's all you have to do. So step 1, find the linearization formula and substitute a for everything else besides x. Now, when they say approximate a number, only that time you substitute x with the number they give you, and then you simplify. And usually to simplify, we do use a calculator if you don't want to use your brain. So yes, you can use your calculator at that time, but you cannot just simply put square root of 3.99 in the calculator and give me the answer. So using the calculator directly is prohibited. Once you find the linearization, then you can use a calculator. But the video I gave you, they actually showed how to find it algebraically, not using the calculator, which was cool. But in your case, you don't have to do that. A is the number they give you. For number 2, okay, so if they don't give you any function, that means you have to find your function and your A. So interesting question, good. Let's try this one. We are approximating 1.99 to the 4. We know from here our x is 1.999. Whatever number they give you, that is always x. Now A, do you know what does A stand for? Approximation. A stands for approximation, that's why it's A. So what number do you have that is approximately close to 1.99999? So that's your A. It's the closest number when you approximate that number. That means the only thing we need to know is f of x. Oh, we get f of x from here. Can you guess what function you're dealing here? X to the power 4. Because if the inside is x, what do we get? X to the power 4. So that's it. And once you know your function, you know how to find the derivative. So we need to know the function only because we need to know its derivative. So if they don't give you the function, it's your job to figure out what is the function, but always make sure you remember whatever number they give you, that's the x. So all you have to do is whatever they give you, replace that number with x, and then you get your function. Once you have your function, you know how to find its derivative. Once you have a derivative, you need to substitute the derivative with the approximation, not the x. The only place where we substitute our x is here. And for everything else, it's always the A, the approximated number. Any question on this? Okay, the next one is differential. Now, differential and dy dx Well, the same, not same. So we have, let's say, tangent cosine. So y equals cosine of x. They're saying that find dy if your x is pi over 3 and your dx is negative 0.05. All we have to do is find the derivative. What's the derivative of y? You must write dy dx because you're doing differential, not the direct derivative. If you do only derivative, you can write y prime, no problem. But here we are finding the differential. So we need to have is dy in one side, dx on the other side. You need to separate them, not together. But I'm going to do that later. For now, first step is find the derivative. Don't use y prime, use dy dx. What's the derivative of cosine x? Negative sine x. And the difference between this and the differential is that differential look at dy and dx separately individually. Okay, so in normal derivative we look at dy dx as one thing, but in differential they look at in two things. We observe the differences separately. If you want, you can write dx over dx just to have the same habit, but then since you're the same thing, they cancel out. So differential means we don't want dy dx together. We want this on the other side. So you multiply both sides by dx, dx, dx. So this dx cancel. You get a simple dy here. And on the other side, you have negative sine of x dx. Even though they are the same thing, dy over dx. But you just look at the differences individually. And then they give us the sine. So they give us the x. Our x is pi over 3. And they also give us the dx, which is 0.05. Do you know what is sine pi over 3? What is pi over 3? Which degree? 60. So what is sine 60 degree? 3 over 2? Radical 3 over 2. Yeah. Square root of 3 over 2. And you're multiplying by negative 0.05. Now negative 0.05, it means pi over 100. You can use calculator to find that number. But you don't have to if you don't want to. But the double negative times the positive, and you have 0.05 times the square root of 3, whole thing divided by 2, whatever that is. And remember, you're allowed to use only scientific calculator. Don't bring any graphing calculator in. That last time. I didn't make the exam yet, so I'm not sure. But if you have a calculator, just put them in the calculator and find out what the number is. Every scientific calculator has a square root function. And also you need to know your sine, cosine, tangent, 60 degree, 30 degree, 90 degree. Pi means radians. So if they give you radians, if they give you pi, it means they give you radians. If they give you like 60 degree, it means they give you degree. So if it's radian in a calculator, you see RAD. If it's in the degree, they give you degree, then you can put DG, the degree mode. It depends on the instructor. For me, I actually like to have degree because I can see the degree. But in general, people work with radians when you work with trigonometry. But I hate radians because I can see them, I can visualize them. for some reason, I don't know why. So one differential, definitely one linearization. Any question on this? Okay, now maximum, minimum. You need to know the difference between local maximum minimum versus absolute maximum minimum. So do you remember, can the end become local maximum minimum? Good. So that's all you have to remember. At the end, it cannot have local maximum minimum. So if you have anything on the end, it can only be global or absolute. Everything else, the local has to be in the middle. For example, here, what is this? A local minimum. What is this? Local maximum. What is this? A local minimum. But this local minimum is also absolute minimum. And at the end, we cannot have more than one absolute max or absolute minimum. Absolute means the highest or the lowest. So which one is absolute? The left or the right? The left. And when they said, what's the absolute maximum value or minimum value? Anytime they ask for value, what do you give them? The x value or the y value? Y. So max or mean value means always the y value. And if they mention the location, where do you have a maximum minimum? Where means location. Location means the x value. Okay? Where do you have a local maximum? Is where we have a local maximum at x equals 1. Where do we have a local minimum? Is that we have a local minimum at x equals 0, x equals 3. So where, anytime you see the word where, is the location, it's the x value. But anytime they're asking for what's the maximum value of this function, what's the minimum value of this function, it means the y value. That's what you have to remember here. Max mean value means y, location means x. Critical numbers. How do you find critical numbers? First derivative equals 0. So critical number or critical value means the first derivative 0. So for any function, whatever they give you, take the derivative, set it equals 0. If your function A has a numerator denominator, then for critical value, you only look at the numerator. Set the numerator equals 0, solve for x. That's it. Do you remember the derivative for absolute value function? If this is your g of x, what's the derivative? The original g of x divided by the entire thing, then multiplied by derivative of g of x. So it's like chain rule, but it's more than chain rule. In chain rule, we have to keep the original function inside and change the outside function, and then multiply by the derivative inside, and the absolute value, you keep your original function, the denominator, and numerator is without the absolute value. And then you multiply by the derivative. Because anytime you set something equals 0, and when you have that thing is fraction, you cross multiply, right? Remember, below 0, the invisible 1. So when you multiply denominator with the 0, what happens to the denominator? It becomes 0. And when you multiply numerator times 1, what happens to the numerator? It stays, right? So you have g of x times the derivative equals 0. The left equals the right diagonal. That's why anytime you have a fraction and you're solving, you always disregard the denominator. Okay, so one question about critical number.
Do absolute value functions have absolute maximums?
No, because unless it's an absolute, it's a negative. So if it's a positive absolute value, it has a minimum. But if it's upside down, only then you have a maximum. Otherwise, it doesn't. So it depends on the function. Okay, so just critical number is if the derivative set equals 0. And now what happens when you're finding absolute maximum minimum of a function in a given interval? So you have a function without the graph. Without using the graph, how can you find the absolute maximum minimum or local maximum minimum of a function in a given interval? The easy steps. Whatever you have, let's say A and B, you need to know what is f of A, what is f of B. So you need to find f of A, f of B, and then you need to find the derivatives that equals 0, solve for x. Okay? Those x going to tell you the location of the absolute maximum minimum. So when you have your x, you substitute that x to find the y value. So how do I write this? You got the idea, right? Solve for x from your derivative to get the x value, to get the y value, you substitute that into function. Oh, f of critical value, I remember. You find the y value for the end, and you also find the y value for the critical value. And then you compare all these things. Whichever is the highest number is the absolute maximum, whichever is the lowest number is the absolute minimum. So 3 steps. Find the n value for the y's, find the y for the n values, and then find the y for the critical values. It does, because when it's closed interval, both n's have a y value. But when it's an open interval, whichever is open, it doesn't have any y value. So you have to disregard that y value. If it's open, it doesn't have any y value for that. For example, the last one, neither 2 nor 7 you're going to replace. So all you have to do is take the derivative and find the y value for the critical value. And that will give you your maximum minimum. And if it's infinity, same thing. You cannot work with the infinity. So let's see, what do we have? We cannot substitute the n's because they're not included. So you go to the derivative directly. Negative 6x squared. What's the derivative? 12x. 84x. What's the derivative? 84. So you take the derivative, set the derivative equals 0, and solve for x. So to solve for x, you just simply add 12x. So we have 12x is 84, divide by 12. We have, can you divide 84 by 12 again, please? 7. We have only one number. So to get the y value, we substitute that back. Negative 6, 7 squared, plus 84x, plus 1000. Whatever that is, that's the y value. Now the question is, when you have one number, how to use the maximum? There are several ways of doing it. One thing is by observing what type of function we have. What type of function we have here? Upside down parabola. Because we have a minus 6x squared. So what is this number here? Maximum or minimum? Maximum. And let's say you have other function. So if you have other function where the shape is unknown, then find a y value before that, find a y value after that, and then look and then observe what do you have. Is it a maximum or it's a minimum? question. So one of these, Rolle's theorem. Do you remember the Rolle's theorem? I also forgot kind of. What's the Rolle's theorem? Is it something about changing the sign or something?
Your endpoint
Are same,
is same, there must exist a horizontal tangent line
maximum or minimum.
between your estimates.
Good, thank you. It has to satisfy three conditions. One is continuity. The other one is differentiable. And then the last one is
And Y values, yeah.
the Y values. Okay. So for this type of question, you substitute 5 and 7 and see what's the Y value. And then they only tell you that it satisfied everything. You just need to find the C. Which C satisfy all three conditions? I actually forgot how to do this. But I did it in class, right? I did it in class. So watch the recording. I don't remember that. There's one interesting question which I did not go over in class. I think is something like this one and this one. So what they're saying that if you know that your derivative is always lying below 5, it's smaller than 5, and you know that your x-intercept is -3, how large your y value can be when your x is 2. Okay. So it's an interesting question because here we are going to use the mean value theorem. Do you remember your mean value theorem? I don't remember the beginning or end. It's something like if you have a function that is continuous on a closed interval, differentiable on an open interval, then there always exists some derivative. So derivative at some number C, which lies between A and B, because the interval lies is between A and B, closed interval. So if you have a function between A and B in a closed interval, then between A and B, there always exists a C. For that C, your derivative is same as the slope of the secant line, which is f of b minus f of a over b minus a. So it's guaranteed that you have parallel secant and tangent line. Okay. So how you're going to use this is that first you find the derivative. So derivative at C, we know it's between f of b minus f of a over b minus a. Now they are telling us your A and B here. Sorry, here, my arrow is wrong. Your function is lying between 0 to 2. How do I know? Because f of 0 means x value 0. F of 2 means your x value is 2. So this is 2, this is 0. That means this is f of 2 and this is f of 0. In other words, this thing becomes f of 2 minus f of 0 over 2 minus 0. They didn't tell us directly, but they gave us enough information to figure that out. And then they also gave us the information is that this f of c is always less than 5. Always. It doesn't matter what number you have for c. For any c, the derivative has the slope less than 5. Now you're looking for the c. So you're not looking for c. You're looking for the y value, this one. how large this can be based on this information. So we know f of 0 is -3 because they gave us already. So we have f of 2 minus 0 over 2. This thing is less than 5. So f of 2 divided by 2 is less than 5. You multiply both sides by 2. So we have f of 2 is less than 10. So we know definitely f of 2 is less than 10. Now, yeah, that's all you can find. They also found the exact value for f of 2.
0, -3. Then 0.
Oh man, thank you. Actually, I didn't notice that. So -3, that gives us +3 here over 2. So we have multiplication. F of 2 plus 3 is less than 10. That tells us f of 2 is less than 7. Not 10. So that's all we have to do. This is an interesting question because of this. The mean value. It doesn't say that apply mean value directly, but you have to know that mean value is actually the right way to solve this. And since I didn't go over in class, I have the solution for both, for this one and for the next one. So I'm planning to give one of these because these are famous questions. Any question on this? This is what they're asking for. How large f of 2 can be? It can be maximum 7. It cannot be anything bigger than 7. One thing I also did not mention in class is that what if your inflection point doesn't change sign? So something with the inflection point, like the next question. Find on the inflection point, and then the next one says find the interval for concavity. So yes, you're going to have one of these examples. Find the inflection point and then figure out the concavity. Okay, let's see. Do I have more? Oh, let's do this one. B. It's simple. To find the inflection point, it connects with the second derivative. The first derivative gives us the critical point, the critical value. The second derivative gives us the inflection point. So what's the first derivative for x to the 4? 4x cubed. What's the second derivative? 12x squared. For the inflection point, you set the second derivative equals 0 and you solve for x. And this x is easy, right? If 12x squared equals 0, x must be 0. Now to figure out concavity, you place them in the number line. We have negative infinity to positive infinity, and then somewhere we have 0. Where we have the second derivative positive, we have concave up. Where we have second derivative negative, we have concave down. Okay? That's the relationship between the second derivative and concavity. Like the first derivative, where the first derivative is positive, function increases. First derivative negative, function decreases. First derivative 0, we have a bump. So second derivative positive means it's concave up. Second derivative negative is concave down. And second derivative 0, it means it changes position. So it not changes the position, I choose direction. It changes the direction from concave up to concave down, from concave down to concave up, right? Exactly. So that's the idea here. What if it doesn't change the direction? So let's say we pick a number x equals -1. And we'll look at the second derivative. Second derivative at -1. So we have 12x squared. Our derivative is what? Positive or negative? Positive. Let's say you're picking a number x equals +1. What's the second derivative at +1? It's still positive. Did it change direction? It didn't. So if some inflection point doesn't change direction, it's not inflection point. Even though you get it by solving the second derivative, but it's not. I'm actually not sure about this, so let me change this. It's not inflection point. In order to be an inflection point, you must change direction. That's the requirement. Okay? And that thing I forgot to tell you in the class. That in order to be an inflection point, you have to change your direction. If you don't change your sign, you're not an inflection point. So this function doesn't have an inflection point. Any question? Do you know the shape of the 4-degree graph? It's just like parabola, but it lies a little bit more on the x-axis. Does it have a concavity problem? Does it have a concavity change somewhere? It's always what? Concave. And see, second derivative is always positive. So if you have something always positive, it means you always have concave up. If your second derivative is always negative, that means you have always concave down. That's why you don't have any change. Or if you don't change your direction, it cannot be inflection point. So I was thinking to give you two. One is for real, find the inflection point, and one is to test whether you can identify whether it's an inflection point or not. Okay. You must. So even this is find the inflection point, but still you have to test it out in order to be the inflection point or not. But I'll definitely mention find the inflection point, find the interval of the concavity. So two stone, you're killing two birds in one stone. And then finally, the last section, it says, use all the information and find a sketch a graph. So this is from your homework. Try it on your homework, and then I want to give one of these because this is not a math problem. It's intelligence question, logic. Do you want me to go over any one of those? A, B. In class, I went over A. And in the homework, you can do your B. I took B from the homework. The last question says, I'll give you one equation. It could be trig, could be polynomial, could be rational. One equation, and find all this information through sketch a graph. And I'll just give one easy, one hard. Hard is for Ellen, easy is for you guys. So these are too small. The first one says vertical asymptote. I'm not going to do anything. I'm just giving you the information. Vertical asymptote exists for rational. If you have a numerator and denominator, then you have a vertical asymptote. If you don't have a denominator, you don't have a vertical asymptote. Okay? To find the vertical asymptote, you set the simplified denominator to be 0. Simplified denominator equals 0, solve for x. So your first goal always should be figuring out whether you can simplify it or not. If it's not simplificable, it takes the denominator test that it equals 0, solve for x. But if it's simplificable, for example, if you have, let's say, x plus 1 over, let's say, x squared, x minus 3. So you can simplify. So if it's simplificable, first you simplify and then you take the original, then you take the simplified denominator. But if you have polynomial, ignore. Horizontal asymptote. For horizontal asymptote, do you remember how to define horizontal asymptote? Good. You observe your highest degree on the numerator and denominator. So horizontal asymptote. A x to the m highest m b x to the highest m, and then you have 3 rules based on your highest degree. If numerator is big, no horizontal asymptote. If denominator is big, what's the asymptote? Y equals 0. And if they both are same, they cancel out, then what's the answer? Yeah, these 3 rules. Critical value. How do you find critical value? First derivative equals 0. Solve for x. Interval of increasing, decreasing. Increasing, decreasing. How do you find increasing, decreasing interval? You take the critical value, place them on the number line, and you test out each interval. Positive derivative means function increasing. Negative derivative means function decreasing. Then you have local maximum, minimum. Once you have your increasing, decreasing interval, try to draw your graph. When you draw your graph, you can see the maximum, minimum easily. And it says find the local maximum points. So if you see the word points, it means the x value and the y value. But if it says maximum, minimum value, it means only the y value. So be careful what they're asking for. Are they asking for the point or are they asking for the value? Inflection point. Inflection point. How do you find inflection point? Second derivative 0, solve for x. Even though it's a point, but actually you don't have to find the y value here. Yes, you can, but you don't have to. But then just because you found them, it doesn't mean you can give me the answer. Once you found them, you need to place them in the number line and then see if they change their direction. If they change, then you accept. But let's say a plus, plus, minus, here they didn't change, so you cannot take it as an inflection point. Only when you see change, it's an inflection point. If they don't change the direction, it's not an inflection point. So you have to test them anyway. And when you test them, you place everything into the second derivative. Next question is concavity. Concave up or down. So second derivative positive means concave up. Second derivative negative means concave down. And you can figure that out with your number line. What do you have next? X and Y intercept. Do you remember in general how to find x-intercept? What do you do? Set y equals 0 and we solve for x. How do you find y-intercept? you set x equals 0 and you solve for y. So if you have x-intercept, y-intercept, increasing, decreasing, continuity, everything, then you simply place everything and then graph. So Alan, what type of function you prefer for this? Definitely not polynomial, right? Polynomial is too easy for you. Alan, what do you prefer for this part? A trig function, a rational function, absolute value function, what type of function you prefer? Trig? Okay. And how about the rest of you guys? Polynomial or rational? Which one? Polynomial? Okay. So I'll give you one polynomial, one trig. Let me write this down before I forget. Either polynomial or trig.